Good evening, friends, and welcome once again to the new session of physics. My dear friends, in the last lecture, we have discussed about the concept of the electric potential, and we have seen that the line integral of an electric field is equal to the amount of work done in moving a charge from one point to another point in that electric field. If you remember, we have seen that surface integral of E dot dl when we move the particle from A to B, it was equal to 1 over 4 pi epsilon naught 1 over 4 pi epsilon naught Q into 1 over RA minus RB. This is, you can say, the work done in moving the particle or the charge from A to B. So this is equal to this, it means 1 over 4 pi epsilon naught Q into 1 over RA minus 1 over RB. What we have presumed in the morning was, if we have a charge Q at origin, due to this charge there will be electric field associated, and if we move a charge from A to, let us say, B, this is the direction of electric field and this is the direction of the displacement. So this was the work done in moving the charge from A to B. Now suppose we want to bring the charge back from B to A. Now in that case, you all know WBA will be equal to 1 over 4 pi epsilon naught Q into 1 over RB minus 1 over RA. This was also explained to you. If we are moving from A to B, it will be RA minus RB. And if we are moving from B to A, it will be RB minus RA. Now suppose we want to find out what is the amount of work done by the line integral in a closed path. We want to find out what is the amount of work done by the line integral in a closed path. That means first of all we have to find this, and then we have to find this. It means total work done for a closed path will be equal to naturally WAB plus WBA. Total work done will be what? The work done in moving from A to B and the work done in moving from B to A. So when we combine, total work done will be equal to 1 over 4 pi epsilon naught Q. This will be common. This will be common. WA plus WB. WA is 1 over RA minus 1 over RB plus 1 over RB minus 1 over RA. Any doubt? Total work done will be the sum of the work done from A to B, then from B to A. This is the closed path. Closed का मतलब क्या होता है? यहाँ से यहाँ गए, यहाँ से यहाँ आ गए, तो this is the closed path. So this is it. Now this as well as this will be common, taken out. So this plus this, तो what happens? ये और ये cancel हो गया, ये और ये cancel हो गया. It means what is the total work done? That is 0. So what we find? We find that the line integral of an electric field along a closed path is 0. The work done or the line integral of an electric field along the closed path is 0. Any doubt to anybody? Is there any doubt? Okay, my dear friends. So today we have done a very important part of the article that we have done last time. Continuation in that, and this is now over. Once again we are going to start with a very important article now, and that will be explaining you about what we call as potential difference and potentials. Potential difference and potentials. Before that, you just do one thing. By the time I start, you revise the concept of potential and potential difference that we have discussed in our class 10 during the definition, and then we will continue with our article. एक बार उसको रिवाइज कर लीजिए. By the time I will start the article for you. So today we are going to start the concept of electric potential difference and potential. This we already know, but here what we will be using the electric field, or you can say using the line integral. Using the line integral. Just now the concept of line integral that we have done, we will use that in order to find out the concept of electric potential difference and potential. Clear हो गया? चलिए. Again what we will assume कि हमारे पास एक कार्टेशियन फॉर्मेट है. We have a Cartesian format where at the origin I have placed a charge plus q. I have placed a charge plus q, and as usual you all know, due to this charge there will be a development of electric field in all the direction. So it will be like this in all the direction, where this is the direction of the electric field. So this is my electric field direction. Now in order to find the potential difference, we have to consider that there are 2 points A and B. There are 2 points A and B inside this electric field where the potential is, let us say, VA and VB. We are considering the 2 points A and B inside the electric field which are having the potential of VA and VB. Any doubt? Now you all know that in order to find the concept of potential difference, let us let us place a test charge of Q naught at this point P. हमने क्या किया, एक टेस्ट चार्ज Q naught को पॉइंट P पर प्लेस कर दिया. वन थिंग इज वेरी ऑब्वियस कि जैसे ही ये टेस्ट चार्ज P पर आएगा, ड्यू टू द इलेक्ट्रिक फील्ड this charge will experience a force. This charge will experience a force in the direction of the electric field. In the direction of the electric field, यानी ये इलेक्ट्रिक फील्ड कहीं ना कहीं इस चार्ज को यहां पर एक फोर्स लगाएगी. And you know what is the magnitude of this force going to be? What will be the magnitude of this force? Very simple. The Q naught multiplied by E. This is the magnitude of the force which will be experienced by this test charge at P due to electric field. Now, if I want that this charge should not be able to move, or if I want that the charge should remain at the same position, I have to make sure that there is a work done against this applied force, and that will be obviously against the direction of this applied force. It means यहाँ पे इस डायरेक्शन में एक फोर्स लगेगी, and according to Newton's third law of motion, you all know that force will be minus Q naught E. Is there any doubt? जैसे ही हम एक चार्ज जिसको हमने टेस्ट चार्ज कहा है, हम Q naught P पर प्लेस करेंगे, इलेक्ट्रिक फील्ड उसके ऊपर एक फोर्स लगाएगी, और उस फोर्स की वजह से क्या होगा, जो चार्ज है वो आगे की ओर धकेला जाएगा. और अगर हम ये चाहते हैं कि वो फोर्स उसको मूव न करे, इक्विलिब्रियम में रहे, तो हमारे पास क्या आएगा, माइनस Q naught एक फोर्स उसको अपोजिट साइड में लगेगी. Now, according to the concept of electric potential difference, you know the definition. Electric potential difference VA minus VB is the amount of work done per unit test charge. Amount of work done per unit test charge. This is your definition of electric potential difference. So difference will be VB. So what I will write, VB minus VA. So VB minus VA is equal to work done divided by Q naught. Work done in moving the charge from A to B divided by the test charge, which is Q naught. Any doubt? Is there any doubt? And we all know that what will be the work done? Work done, that is equal to force into displacement. Force into displacement. Force into displacement. And what is the displacement? That is dl. What is the displacement? That is dl. If the force is being applied, so let us say this force makes the movement along AB for a small distance dl and reaches to the point Q. तो F क्या है हमारा बेटा? F is minus Q naught E and multiply by the displacement, that is dl. So WAB is equal to minus Q naught E into dl. Any doubt? अब यहां पर क्या है? Minus Q naught and the total work done will be equal to WAB will be equal to integration to minus Q naught will come out and I will be left with EDL from the limits A to B. This is the work done while moving it from P to Q, and when we take the work done for the entire you can say AB path, it will be integration. Now because this minus and this Q, that means charge is constant, so it will come out and I will be left with the surface integral of E dot dl. Any doubt? Is there any doubt? Now we know what is VB minus VA, WAB divided by Q naught. Put this value of WAB here. So what I will get? VB minus VA is equal to minus Q naught E into surface integral of E dot dl from A to B divided by Q naught. This is W and this is Q naught. So Q naught and Q naught gets cancelled. So what is VB minus VA? That is equal to minus integral of E dot dl. यहाँ से एक चीज बड़ी क्लियर हो गई कि लाइन इंटीग्रल का नेगेटिव, दैट इज योर पोटेंशियल डिफरेंस. लाइन इंटीग्रल का नेगेटिव, that is your potential difference. So hence the electrostatic potential difference between the 2 points is the negative of the line integral of the electric field between the 2 points A and B. So this was the article for today. Rest we will continue in our next lecture. Till that time, if you have any doubt, get back to us. We are always there. And keep revising as usual. Whenever I say this, you should follow the instructions. Take care of yourself. Do good and stay safe. All the very best. Thank you very much. God bless.